Ever wondered where the metals that power our world come from? From the smartphone in your pocket to the car you drive, it all starts deep within the Earth. Today, we're digging into the incredible story of how our planet creates hidden treasures through a process called ore deposit formation. Get ready for a geological journey millions of years in the making. So, what exactly is an ore deposit? Simply put, it's a natural concentration of valuable minerals that's high enough to be mined economically. Think of it like this. Minerals like gold, copper, and lithium are scattered all over the Earth's crust in tiny amounts. Ore deposit formation is the series of natural processes that gather these scattered minerals and concentrate them in one spot, turning a geological curiosity into a valuable resource. These processes are incredibly slow, often taking millions of years, and involve a powerful combination of heat, pressure, fluid movement, and complex chemical reactions. Let's break down the main ways the Earth cooks up these treasures. There are 5 major mechanisms, and each one creates different types of deposits. First up, we have magmatic processes. This all starts with magma, which is molten rock beneath the Earth's surface. As this magma slowly cools and solidifies, different minerals crystallize at different temperatures. Heavier, denser minerals, like chromite, magnetite, and valuable platinum group elements, often sink and settle at the bottom of the magma chamber. Over time, these layers build up, forming rich, concentrated deposits. Imagine making rock candy, but on a planetary scale with immense heat and pressure. That's essentially how magmatic ore deposits are born. Next, we have one of the most common and important mechanisms, hydrothermal processes. This is where hot mineral-rich water comes into play. Think of it as the Earth's natural plumbing system. Deep underground, water gets heated by magma sources and becomes a powerful solvent, dissolving metals from the surrounding rocks. This superheated, metal-laden fluid then travels through cracks, fissures, and faults in the Earth's crust. As it moves into cooler areas, the water can no longer hold on to its dissolved minerals. So they precipitate out, filling the cracks and forming veins of ore. This process is responsible for many of the world's most famous deposits, including gold, copper, tin, lead, and zinc. It's like a high-pressure geological kettle depositing precious metals instead of limescale. Our third mechanism is sedimentary processes. These happen at or near the Earth's surface and involve water, but in a very different way. One method is chemical precipitation. For example, ancient oceans contained dissolved iron. When photosynthetic organisms began releasing oxygen into the atmosphere and oceans, it caused the iron to rust and fall to the seafloor, creating massive layers that we now mine as banded iron formations. Another sedimentary process is physical sorting, which creates what we call placer deposits. Rivers and streams wash away lighter sand and gravel, leaving behind heavier, durable minerals like gold, tin, and diamonds in riverbeds or on beaches. This is exactly what early gold rush miners were looking for when they were panning in rivers. The fourth method is metamorphic processes. Metamorphism is what happens when existing rocks are transformed by intense heat and pressure, but without melting. This can happen during mountain building events, for instance. The extreme conditions can cause minerals within the rock to change, realign, and migrate. This process can remobilize scattered metals and concentrate them into new, economically viable deposits. Some gold and graphite deposits are formed this way, where the planet essentially squeezes and bakes the rocks to concentrate the good stuff. Finally, we have weathering and supergene enrichment. This is a surface-level process driven by weather and rainwater. As rain seeps through the ground, it can dissolve minerals from the upper layers of a rock body and carry them downwards. When these dissolved metals reach a certain depth, often near the water table, the chemical conditions change, causing them to reprecipitate. This process can significantly enrich the concentration of metals in a lower zone, creating a supergene deposit. It essentially takes a low-grade ore body and concentrates it into a much higher-grade, more valuable one. This is how we get rich deposits of bauxite, the primary ore for aluminum, and how some copper deposits become much more profitable to mine. So, why is understanding all this so important? Well, it's absolutely critical to our modern world. The metals sourced from these ore deposits are the building blocks of our technology. We need copper for our electrical grids and wiring, lithium and cobalt for the batteries in our phones and electric vehicles, and rare earth elements for everything from wind turbines to high-tech electronics. Without these geological processes, modern civilization as we know it simply wouldn't exist. Beyond technology, the economic importance is huge. The mining industry creates jobs, drives development in regional areas, and is a major contributor to national economies around the globe. It's a fundamental part of the global economic engine. Furthermore, understanding how ore deposits form is key to finding new ones. Geologists use this knowledge to predict where new resources might be hidden. By studying the geological history of a region, they can identify areas that had the right conditions for magmatic, hydrothermal, or other formative processes. This makes exploration more efficient, less costly, and reduces the environmental footprint by targeting efforts more precisely. It's all about knowing what to look for and where to look. This knowledge also helps us manage our resources sustainably. By understanding the size and nature of ore deposits, we can better assess how long these resources will last and plan for the future. It allows us to make informed decisions about resource allocation and to develop strategies for recycling and finding alternative materials. Lastly, it has major environmental and policy implications. Knowing the geology of an ore deposit helps in planning a mine to minimize its environmental impact. It also informs how the land can be reclaimed and restored after mining is complete. This geological knowledge is crucial for developing responsible resource management policies that balance economic needs with environmental protection. In short, ore deposit formation is the Earth's natural way of concentrating the elements we need to build our world. From the fiery depths of magma chambers to the slow trickle of rainwater, these complex geological processes create the hidden treasures that fuel our economies and power our technological progress. By understanding this incredible story, we can better find, manage, and sustain the resources that will shape our future. Thanks so much for watching. If you found this journey into the Earth's treasures as fascinating as I do, don't forget to hit that like button, subscribe to the channel, and ring the bell so you never miss an exploration. Let me know in the comments which mineral you'd like to learn about next. See you in the next video.